Okay, so in this last clip on the double integral, I'm gonna teach you how to use the double integral to find the volume of the solid bounded above by the surface over the region, which turn out can be rectangle or turn out to be the general region. So you see that this one you have is kind of a prism or a box, okay? So you have the surface on top given by the equation z equal to 6 minus x. And you see the bottom guy, you have x lie between 0 to 3 from this picture. So you see that your x lie between 0 to 3 on the x-axis, and you have y between 0 to 4 on the y-axis. Okay, so you're gonna find the volume of this solid by just integrating this function. So the surface turned out to be z equal to 6 minus x. So the volume, if you use the double integral, so it's gonna be the integral over rectangle. Okay, and the function turned out to be 6 minus x, which is the blue function. Okay, and you're gonna have the x dy, and you see that this translates to 6 minus x dx dy, and x gonna run from 0 to 3 and y gonna run from 0 to 4. Okay, so in this case, it's gonna look like that. And you gonna just calculate the inside. The inside turned out to be 6x. Okay, so you integrate, it's gonna be 6x minus x squared over 2 from 0 to 3. And this one, you see that it's gonna be, so it's gonna be 6 times 3, and you have 3 squared over 2. So this would give you, okay, so this would give you, so you have x and y. Okay, so this would give you what? This would give you 18 minus 9 over 2. So it's gonna be 36 minus 9 over 2 over 2. So it's gonna be over 2. So it's gonna be 27 over 2. Okay, so this is going to be 27 over 2. So this one is the inside, and the outside integral turned out to be integrate 0 to 4 dy. Okay, so it's going to turn out to be integrate 0 to 4 dy. And in this case, it's going to be 27 over 2 times y from 0 to 4. So it's going to be 27 over 2 times 4 minus 0. And this will give you 54 for the final answer. So this one, you can use the double integral in order to obtain the volume of the solid bounded by this surface. However, this surface and this solid look familiar. So you may use the geometry from your high school in order to find this volume instead. So let's try to find the volume by just using your high school geometry. So you see that the height here on this side will be equal to 6. And you have the height here on this side. So you have x equal to 3. Okay, so you have x equal to 3. So you're gonna get z equal to what? So the height here when z will be equal to 6 minus 3. So it's gonna be equal to 3. So the height on that side turned out to be equal to 3. Okay, so this one is gonna be the height Okay, so x equal to 3, you plug in. So this allows you to know this height from your high school geometry. So you get 3, 4, and 6. And if you flip the picture a little bit, the thing that you get will be the picture of a trapezoid. Okay, so you have 3, 6, and you have 4. Not 4, sorry. So this one will be 6, will be 3 after I flip the picture. And you need to know the green one here, the green one. So the green side here turned out to be 3 from the picture. You see 3? You see 3. So this one is 3 because of what? This one is x. Okay, so you see, and this one will be this side. Okay, so it's going to be 3, 6, and 3. And this one gives you a trapezoid. So the area will be equal to half of the sum of the parallel side times the height, which is 3. Okay, so it's going to be half of the sum of the parallel side times 3. So this one will be equal to what? Equal to 27 over 2. Okay, so it's going to be the area equal to 27 over 2. Let me use the green color. 27 over 2. And then what? And then you're gonna compute the volume. So the thickness for this one will be the yellow guy. Okay, so this will give you the thickness. The thickness in this case equal to 4. How would I know? It's going to be here. Okay, so this one is going to be the thickness. Okay, so the thickness equal to 4. So the volume turn out to be the area multiplied by the thickness. So it's going to be this guy multiplied by 27 over 2. Okay, and it's turned out to be the same number, 54. And the calculation is look almost the same. Okay, so this one you can use geometry in high school to see that the volume of this prism turned out to be 54, and you can use the double integral and you get 54 as well. Okay, so you obtain the same value here. Okay, so that correct? The next one is going to be you like to find the volume of the solid bounded by the plane x plus 2y plus z equal to 4 in the first octant. The first octant means x, y, and z is greater than or equal to 0. So let's try to sketch the region a little bit. So you're gonna sketch the plane. How could we sketch the plane? We never learned this one, right? So let's try to sketch by just imagine that you are having x, y, and z. Okay, so you are having x, y, and z. So you have x, y, and z in 3-dimensional. Okay, so you have x-axis, y-axis, and z-axis. So it's going to be plane that is going to turn out to be plane x plus 2y plus z equal to 4. So the way to sketch is going to be you're going to find x intercept. Okay, x intercept means you're going to have y equal to 0, z equal to 0. X intercept will be just you plug in plug in y equal to 0 and z equal to 0. So you're gonna get x equal to 4. In a similar way, you're gonna find y intercept. So y intercept, you're gonna plug in x equal to 0, z equal to 0, and you're gonna have 2y equal to 4, so you get y equal to 2. And you have set intercept. So set intercept will be you're gonna put x equal to 0, y equal to 0, and you solve for set, you get set equal to 4. So you see that it's gonna be 4 for z, 4 for x, and 2 for y. Okay, so you see that the plane turned out to be, the plane is gonna be this one. Okay, so let me draw the picture for you. So this one will be this plane. Okay, so it's gonna be the plane that in the first octant, if you go to the corner of your room, okay, so you look at the corner of your room, so you have this corner and you just use a piece of paper like this. Okay, so you use the piece of paper like this to put into the corner of your room. You see this plane, the plane will be just a piece of paper, and you're not gonna have anything, so it's not gonna be bended like this, or it's gonna be plain like this, and you put into the corner of your room, and this one you're gonna see that it's gonna be kind of triangle that you have. So this one is your plane. So this one is your plane. X plus 2y plus z equal to 0, or equal to 4, sorry. And this one will be, you solve for z, so it's going to be 4 minus x minus 2y. Okay, so this one will be your surface. Okay, so this one will be your surface. And let me emphasize on this one a little bit, that the plane will be the thing that I dotted. Okay, so it's going to be the piece of paper here. Okay, so it's not going to be below. Okay, so the plane will be just thin like this one, and it's going to be this plane. Okay, so imagine that you have the triangle on at the corner of the room. Okay, and you see also that the region is down here. The region S is on the floor. Okay, so this one is on the floor. The region S, if you draw the region S in two-dimensional, the picture turned out to be, so the picture turned out to be, let me, okay. So you have X and Y, you have X, Y like this, and you have the region S, you have Y intercept equal to 2, and you have X intercept equal to 4. Okay, so it's gonna be Y and X. So you have Y, you have X. So you have Y intercept equal to 2 and 4 like that. And this one will be just this guy, okay? So this one will be your region S. Let me use the green color. It should be the green color for this one, okay? And the region S, okay? So the region S is down here. Okay, so this is the region is down there. And this has been the line. Okay, so you see that this one is the region S, and this one is gonna be 0 to 4 and 0 to 2. Okay, so you see where is my S in 3D? In 3D, it's gonna be on the floor. However, in 2D, it's gonna be this triangle. And the thing that you're gonna do is gonna be, you're gonna try to find y equal to, okay? So we need the equation of this line. What is equation for this line? Equation equal to what? So in order to obtain the equation of this line, you need 2 points, okay? For 0, 0, 2. Okay, so you need 2 point for 0, 0, 2. So you're gonna find the slope. The slope will be just 2 minus 0, 2 minus 0 over 0 minus 4. So the slope will be negative 1/2. Okay, so you have the slope equal to negative 1/2, and you're gonna have point which is 0, 2. So you have y equal to negative 1/2 x plus 2. Okay, so 2 here is already y-intercept. Okay, so this one I use the slope intercept form. Okay, or you can use point slope form. It give you the same answer. Okay, if you use the point slope form, you get the same answer. It's gonna be y minus 2 equal to negative 1/2 x minus 0. And then you move negative 2 to the other side, so you get positive 2. So you get y equal to negative 1/2 x plus 2. Okay, and this one will be the equation that you're looking for. So it's going to be y equal to negative 1/2 x plus 2. Okay, and then you're gonna set up the double integral over s. So you're gonna get the volume turn out to be the double integral over s of the surface dA. Okay, so you see that you can have x run first, or you can have y run first. Okay, and if you have y, it's going to be fraction. So you see that if you have equation in terms of y, it's turned out to be fraction. It's kind of difficult to compute. Okay, so this one fraction. So if you have equation in terms of x instead, so you get x equal to what? X equal to, it's kind of difficult for me, 2 minus 4, 4 minus 2y, right? So you have x equal to 4 minus 2y. You solve for x, basically you just move 1/2 x to the other side, and you have minus y, so it's going to be 2 minus y multiplied with 2, so it's going to be 4 minus 2y. Okay, so you see here it's going to be no fraction. Okay, so in this case, this one should be easier. So you have x equal to, and the volume that you're gonna have is gonna be, you're gonna have your surface, which is 4 minus x minus 2y. Okay, so you have 4 minus x minus 2y, and you're gonna have the x dy. Okay, so you're gonna have the x dy, and you see that if you have the x dy, you're gonna have x run first. So x gonna run from x equal to 0. Okay, so it's gonna be from x equal to 0 to the green function, which is x equal to 4 minus 2y. Okay, so it's going to be x equal to 0 to x equal to 4 minus 2y, and y gonna cover from 0 to 2. Okay, so it's y gonna cover from 0 to 2. Okay, and then this one will give you the volume. Okay, I will leave this question for you to integral, and I will give you the solution when we have the recitation. Okay, one thing that you may think that this question is so hard, this one is going to be kind of easier if you can ignore this guy, right? So this one seems hard because you have to use algebra a lot. I explain this one way because I like you to see the correct way to do. However, if you see that this one is going to be the surface set equal to 4 minus x minus 2y, and this one is on the floor. On the floor means z equal to 0. Okay, so it's on the floor. It's on the floor mean the value of z equal to 0. So the equation of the green line here, the equation of the green line here, turn out to be z equal to 0 of the surface. 0 equal to 4 minus x minus 2y. Okay, so it's gonna be very simple. So if you feel that this guy seems difficult, you just think that on the floor means z equal to 0, and you would just put 0 here. Okay, you just put 0 here for z. Okay, so you just put 0 here for z, and you see that you get the equation correctly. Okay, so you have x equal to 4 minus 2y. This is the correct equation that you decide. Okay, so I teach you in the hard way first, and I tell you now that you can get x equal to 4 minus 2y in a simple way also. Okay, and the way to set up is going to be just x equal to 0 to x equal to 4 minus 2y. Okay, and this one will be, I ask you to compute this one for me, and I will give you the number. Okay, so this guy will be 16 over 3. Please calculate for me. Okay, I show you when we have the recitation. Okay, the last one, we like to find the volume of the solid bounded above by z equal to fxy equal to e to the y square, and below by the triangle with the vertices 0, 0, 0, 1, and 1, 1. So for this one, it's a little bit simple if you be able to graph this guy first. So you're gonna graph the rectangle for me. So you see that you have 0, 0, 0, 1. 0, 1 is going to be a y, and it's going to be 1, 1. So it's going to be 3 points like this. So it's going to be 1, 0, and this point will be 1, 1. Okay, and the triangle that you have is this triangle. And again, we have seen this one before. This guy is y equal to x. Okay, so this guy is y equal to x, and you have y equal to 0. Yeah, not y equal to 0. So you have x equal to 0, which is that line. Okay, so you have x equal to 0. Okay, and you're gonna have what is called y equal to 1, right? So this one is going to be y equal to 1. And you're gonna have the volume equal to the double integral over s of e to the y squared dA. And you're gonna just set up e to the y squared dx dy. Okay, so it's going to be e to the y squared dx dy, and you try to set up this way. So it's going to be x equal to 0 to x equal to y. Okay, so it's going to be x equal to 0 to x equal to y due to x run first. Okay, so due to x run first. And then you have y gonna cover from 0 to 1, as you can see. Okay, how would I know it's y gonna cover 0 to 1? See the picture. Okay, so this is gonna be 0 to 1 for y. And x, how would I know it's gonna be x equal to 0 to x equal to y? Go run this way. Okay, so x equal to 0 to the other side of the triangle. And you see that you integrate this one. Okay, so you integrate this one, it would give you e to the y square, and here it turned out to be constant. Okay, so multiply with x from x equal to 0 to x equal to y. Okay, kind of fast. And you have integrate 0 to 1, you have e to the y square times y minus 0 dy. Okay, so this one is dy. Dy is dy from here. Okay. And then you're gonna use the substitution. So you let u equal to y square, du equal to 2y dy. So you get y dy equal to du over 2. So this would give you integrate of 0 square to 1 square of e to the u du over 2. Okay, so dy turn out to be du over 2. And then you gonna just have 1/2 e to the u from 0 to 1. So it's gonna be 1/2 e to the first minus e to the 0. So it's gonna be e minus 1 over 2. Okay, so this one. So if you need more space for this example, please use this blank page. Okay, so I intended you to use this one. So this one is gonna take you longer than this one. However, when I set this one up, because the record that I need, so it's gonna be I left the one blank page for you, and you can move this one to use later for the thing that you need, maybe in the calculation, or you may take note. Okay, so this page I intended to tell you about the quiz and anything. Okay, so that's all for the double integral. We have 4 clips. Please study them and please do the homework that I left you from time to time here. And I will use the recitation that we're gonna see each other to complete everything up with you. Okay, so try to do this one on your own first, and we're gonna see each other again during the recitation. Okay, that's all. Thank you.